Okay, for today, it is called linear programming. That is a fancy dancy name, okay? But we really are just writing equations. Like if I said Bob makes $5 an hour plus 25 bucks for showing up, that'd be an equation like this. You see what's on the board? Would you please write me an equation for this? This is a real life situation. I'm not going to use the kid's name, but he has a DJ business, and so he is going to be going and doing a wedding job. And so here's his rate. He charges, and I'm going to change the numbers along with changing the names to make it less identifiable with this kid. But say he charges $80 an hour to come and DJ your wedding or your grad party or whatever you want to DJ. Okay? Would you please write an equation for that? It seems like you just said something. How am I supposed to write an equation for that? You always use a y and an x. And if you pattern it after what I just did a second ago, it should be easy. Check with the kid next to you and see if you have the same equation for... Did you get y equals 80x? Raise your hand if you did. Okay, awesome. And I suggested maybe that if he has a really small job, that would be a pain in the butt, because if, let's say the person only wants to hire him for a half hour, and then he's only going to make $40, and he has to haul all the stuff there, set up for DJing, you got to have like a lot of stuff. You got to have big speakers, you got to have lights if you're going to do a good job of it. Anyway, bottom line, it would be a lot of setup for only, well, then you could structure your rate differently. So I suggested something like this. What if you charge $200 to show up, and then only $25 an hour after that? Would you please write an equation for that? $200 to show up. All right, what did you get for that, sir?
Y equals 25x plus 200.
Yes. Now, if he typically has jobs that run like 4 hours, like nobody wants a DJ for like 24 hours straight, right?
Yes, I do.
Okay, fine. But not many people hire him for those jobs. Then, do you get if he has a 1 hour job? This one would pay how much if it was a 1 hour job?
$80.
$80. What if he has a 1 hour job on this scenario? $225. Now, the people hiring him might be like, well, I'm not going to hire you to do 1 hour jobs. And he could be like, thank you, because I don't want to do all that work for $80. You know, like I'd rather only do jobs that are bigger than that. All right, so where's the break-even point? The break-even point is where he would get the same amount of money under either pricing scenario. Use your big brain and try to figure out what to do to find the break-even point. Don't just guess and check like, oh, I'm going to check 2 hours. Now I'm going to check 2.5 hours. Now I'm going to check 3 hours. That's the really slow and not very intelligent way to do it. Guess and check does work. I'm just saying, be smarter about it. Be more strategic. So did you realize you had two equations with two variables, and therefore you can solve the system? I would use what's called substitution. Y is 80x. So this y right here, you can cross it off and you can put in 80x. Raise your hand if you started that way, because that was smart. Awesome. Then solve it. If you haven't already done this, take a moment and solve 80x equals 25x plus 200. Most of the class, I think, knows how to do this the most efficient way. But there's a good chunk of kids who, by accident, do the wrong step first. What you should do is get rid of the smaller of the variables first. A lot of people mess around with the 200, like I'm going to subtract 200 from both sides. Don't do that, because instead, you want to start by getting rid of the smaller of the two variables. So it's either negative 25x or we would have done negative 80x. And you could do negative 80x and it would work. The problem is you'd end up with an extra negative that you don't need to have. If you always get rid of the smaller of the two, 25 is obviously smaller than 80. That's the smart way to do this. All right, so now those are gone. And 80 minus 25, 55x equals 200. And what's my final step, sir?
Dividing by 55.
Dividing by 55. Did you get a final answer? You probably left it as some weird decimal, right? Use your calculator. Divide them. You can use the calculator on your iPad too. That would work. 200 divided by 55. It's not a nice number. It's not like a super nice number anyway. If I had to estimate it, would you agree that 200 divided by 50, which would be about 4, would be a pretty close estimate? Okay, so what was the actual answer? 3.63. Estimates are good, though, to get an idea. 3.6 and 4 is not too far apart. 3.63 hours. Think anybody's going to hire him for exactly 3.63 hours? Of course not. But that means at 4 hours, one of these is a better deal for the DJ. Think about it. Which pricing structure would you want if you're the DJ? And they're going to hire you for 4 hours. Do you want the 80x? Yeah, because for each extra hour, you're going to make an extra 80 bucks. He told me that he had an 8-hour job for a wedding. Which system should he use? 80 bucks an hour. Yeah. All right. Okay. What if he had a 1-hour job?
25x plus 20.
Yeah. Now, one other thing as a business, you could have both systems. You could say, for jobs that are under 3 hours, then I'm going to charge this way. The 200 bucks an hour, or 200 bucks to start with, plus 25 bucks an hour. And for jobs that are more than 4 hours, I'm going to charge this way. You can do that. You can have two different systems. All right. So how is this like what we are doing? Well, a lot of things. Number one, you have to solve systems of equations like we just did there. Where you have two equations and you set them equal and you solve it. And the problem with what we just did is we didn't ever actually get the y. Do you get what I'm saying? We figured out x, which is that at 3.63 hours they break even. But how much does he make? Well, then you can put it in either equation and find out how much does he make on 3.63 hours. Do you get the 80 bucks an hour one's a lot easier to use? You just take 80 bucks times 3.63. Use your calculator if you have to. Split screen your iPad and you can have them both up at the same time. Did you get 290.4? All right. Okay, so this is a point on a graph. 3.63 comma 290.4. Do you get how that 3.63 comma 290.4 is a little bit vague, but yet if you call it in context and you say for this many hours you'll make this much money, it makes it much better to use units. Moral of the story, be careful with your units in this unit. Because at the end, if you just say the answer is 2.6, I'm going to mark it wrong. Because these are all word problems that are about stuff. Like, he should work for 2.6 hours. Or, just make sure you have the units in your answers. More than ever, you're going to lose points for units if you don't have them. All right. So then how about inequalities? Well, here's a typical inequality scenario. So with inequalities, you just have the same kind of problems, except they're going to say things like greater than, and you'll include a greater than symbol. Like, he says, I am only going to take jobs greater than 1 hour. Do you get that means he technically is not going to take a 1 hour job? Okay. So he'd take jobs that are larger than an hour. Maybe he only does minimums a half hour, so then I'll take an hour and a half job, but that's it. That's the smallest I'll go. Okay, so that's how the real world changes signs. And things like not greater than can get confusing. Not greater is the same as like less, right? All right, so let's see if you really understand that part. I'm going to go off to the side here, and I want you to do the same. Would you please write me an equation that's got an inequality for this? The daycare will only take kids that are at least 8 years old. Write an equation for that. You might be like, well, which one's y and which one's x? That does bring up a very good point. You should define your variables. Like in our last problem, x was the hours and y was how much money he was making. In this case, the daycare is only going to accept kids that are of age 8 or older. I would go like this. If A is age, you get how I defined my variable? Then A needs to be greater than or equal to 8. Raise your hand if you had that one right. Okay, awesome. And don't forget this defining the variables part. It's a big deal. Because if you have two different variables, like we will a lot, like one of them might be you're a manufacturer and you're going to manufacture two things, jet skis and stand-up paddleboards. Well, then you need to define early which one's X and which one's Y. And there's no like one that has to be a certain thing. Usually if I'm picking though, if I got two things, I'll just make the first thing they give me X and the other thing they give me Y. Or you can even change variables. Sometimes you can like use P for pianos and, you know, C for cars. All right. So, write one more equation for me. The amount of radiation that you can handle is human beings must have no more than 10 kilojoules of radiation in their lifetime. I totally made up the 10 kilojoules thing, but I can tell you this. There is a limit to how much radiation you should have. Like, do you get that if you have your teeth x-rayed, you got a little tiny bit of radiation there? And a lot of that would be bad. If you kept getting your teeth x-rayed like every day for years and years, you very well might get brain cancer. Because like your body can only handle so much radiation. A little bit, it's no big deal. You have it over and over and over again, it's a big deal. All right. So not more than, isn't that pretty much the same as less than? And then I gave that number of 10 kilojoules. So your amount of radiation, I used R, and I'm going to say R is radiation. And R is less than or equal to 10. And then kilojoules, I don't know, I'm going to put kJ just to make sure that I got my units in there. Okay, I do not know the exact number, but I know that they have to watch out for that because in different kinds of surgeries and stuff, sometimes they give you some radiation to cure you from cancer or whatever, and they give you, I know that in one situation that I had to deal with, they were talking about, well, we can give you this, but it's your lifetime dose of radiation. So like, if we do this, then you can't have any more. Because you kind of used up how much your body can take. So that's an example of less than or equal to. All right. Okay, so let's go on to some other things. What if they just have a single variable? Well, then you can graph them on a number line like this. Okay, there are more than 10 people in line. X has to be what? Greater than 10. And here's 10. You pick a spot, I don't care which one. And then if you circle it and you go like arrow to the right, that's how you graph X is greater than 10. Notice I left an empty circle. What if I had said X is greater than or equal to 10?
It would be a filled circle.
Filled in circle. And then I put an or equal to, so. All right, good. Next slide. There are at least 10 people in line. Ooh, that one gets people sometimes. Does that mean greater than or equal to, less than or equal to, or just equal to?
Greater than or equal to.
How many of you had that one? That is the correct answer. Okay. All right. All right. So, hold on just a second. To the next one. Susan called to say the only tickets available for the Adele concert are in row 10 or above, but less than row 40. It's not realistic. Unless somebody bought out all the cheap tickets, I suppose that's possible. But all right, 10 or above, how am I going to write that? X is greater than or equal to 10. But less than row 40. X has to be less than 40. Can you put that all in together into what I call a sandwich? Yes. I like to put the X in the middle, a small number on the left, big number on the right. You always do it that way. If you're going to write a sandwich one, variables in the middle, small number on the left, big number on the right. And then if you think about it, then your signs are always going to be less than signs. It's kind of weird, but it could be less than or equal to, or just less than. If you put the small number here and the big number here, you would never have a greater than sign like that. You would only have less than signs. Let me get back to the right spot here. There we go. So, final answer, less than. And it can be equal to on the 10, and it can't be on the 40. So here's my final answer. 10 is less than or equal to X, less than 40. Here's 40, 30, 20, 10. Let's say that's 10. And I'd have a filled in here, and an empty here, and graphed like that. Okay, next one, two variables. Again, this is a very typical question. X is the number of pounds of jelly beans. Y is the number of pounds of lemon jelly beans. So you got strawberry versus lemon. Did it really X matter? It didn't matter. You just had to pick one. Because otherwise you get really confused in the problem later if you don't know which one's which. So they said X is going to be strawberry and Y is going to be lemon. Write an inequality for this. Does that say to graph it? No. Hint, you have to have X related to some numbers and Y related to some numbers. Let's say it's like this. Would you please figure out the two equations that you get from this little tiny story problem? I'm going to pause while you give that a try.
I had X is less than 5 and Y is less than or equal to 2.
X less than 5. Y greater than or equal to 2.
I had less than or equal to.
Less than or equal to. My bad. Okay. Does anybody have a bone to pick with his answers? How many of you agree with his answers? All right, good. Okay, now can you put this one in a sandwich? No, you can't. Can you even graph them on the same number line? Not on the same number line. But how could we graph this if we had a graph like this? If this is the x-axis and this is the y-axis, hint, x equals 5 is a spot like, here's 5. X equals 5 is a line that runs like that. How would you do x is less than 5? You'd shade everything where x is less than 5. How would you graph y is greater than or equal to 2 then? Well, here's where y equals 2. And it's greater than that. What are things that are double shaded? They're your answers. Yes? Oh, good point. And if you're talking real world, you brought up a really good point. We have to watch out for things that are not possible, extraneous answers. You can't have negative jelly beans. And you can't have negative, what are the other things?
Jelly beans.
Oh, the different kinds of jelly beans. Okay, lemon and strawberry jelly beans. You can't have negatives of those. So good point. And those are extra equations that we call real world constraints. X has to stay bigger than or equal to 0. You can have 0 of something, but you can't have negative of it. And Y has to stay greater than or equal to 0. So now you could write a little mini sandwich for each of these if you wanted to, or you can just keep them separate. That's a line. It's the line right on the y-axis. X equals 0 is the y-axis. And that's a solid line because it can be 0. And this other line is a solid line on the x-axis, and that's where y equals 0. All right, let me show you a big picture of kind of where we're trying to get to. By the end, you're going to be graphing them like this, and you're going to have one line that looks like this and a shaded underneath it, And you'll have a different line that'll look like this. That's like shaded underneath that. And then you'll have those real world constraints, which would mean you can't go less than 0, so it has to stay on this side of that line. And one more, real world constraint has to be above 0 here. And then your final answer would be something like this. See that scribbled in part that I just did? That is called the feasible region, because the things that are in there are feasible answers to the question. Now, I didn't do the exact strawberry and jelly bean question. Strawberry versus, what's the other one? Lemon. But that's how a typical question will look, is you'll graph 3, 4 things, see where they all overlap. And I'm a realist. I don't think that you are going to actually check every single problem. But on a test, do you get, if you only have 4 R3s, might be smart to take a second and check it. Make sure you do it right. So how the heck do you check it? You take one of the numbers that's shaded in. You grab any of those dots, like, oh, that one, 2, 4, that's actually 4, 2. And I check it by sticking it in my equations and making sure it works. The shaded ones are supposed to work. What do you think the not shaded ones are supposed to do?
Not work.
They're supposed to not work. All right, so let's get to one of those. I'm going to skip through a bunch of these. This is kind of like the when it's done, what's double shaded. I personally don't like it when you use multiple colors because I think it's really hard to figure out where it's been double shaded. I know this is the place it's been double shaded, but I still feel like it's easier if you just shade a little bit on each side of a line. So if I asked you to graph this, y is less than or equal to 2x plus 5. First, I'd have you graph y equals 2x plus 5. It's a line that has a slope of 2 that hits here at 5. And if it says less than, you just shade underneath it. You catch what just happened there? All right, that cell phone. That cell phone that you just picked up twice in the last 2 minutes, put it up on my desk. And if you have your phone out, it's very tempting. It'll be too tempting. All right, so next piece, after you have shaded just a little bit, I know some people want to use your highlighter really bad, so you want to highlight the whole area underneath it. You can, but I'm telling you, when you have 5 lines and you've highlighted 5 different colors, trying to figure out what the color is that is the mixture of all of them, that's not going to be very fun. I would recommend just a little bit of shading on one side of the line like I just did. That way, when you have another line like this and a little bit of shading, you can kind of still tell where they overlap. Your final answers usually look like this, and they usually can't be negative. And so there would be my feasible region in this case. And big picture, the answers are always the corners. That's where the 2 lines intersect. Do you remember on my DJ question? We came up with like 3.63 hours. That was where they intersected. The answers are always going to be these spots where the 2 lines intersect. There. That's pretty much everything. Now, let's get to the end. And I have inserted the homework right here. If you find the homework, we'll do some of it together here. We're going to skip problem 2. And we're going to skip problem 3. I'll help you start if you're willing to do number 1 with me here. You don't have to, but I'd recommend getting 1 done. X is greater than or equal to 1. Here's the line, x equals 1. It's like the y-axis. And then I'd shade a little bit to the right. Next, this hits at 1 and has a slope of 1. So that's an equation. Looks like that. And then it says greater than. That means you shade above it. And last but not least, the line y equals 8. Here's the line y equals 8. And it says less than, so I'm shading it under it. Where do they all overlap? I'm going to extend this blue line out a little bit further. And there's what's called the feasible region. That's where all the shading overlapped. And on the big hard, complicated questions, the answers are always going to be the corners of that. All right, I think you got the idea. It's just the beginning. Got a lot more to learn later this unit. That's all I got for you for today. And then on the back side, we are going to skip problems 6 and 7. Makes it a very realistic, doable assignment. All right.